Looking at the integrand e to the 2y plus 1 over e to the 2y, I'm thinking that exponentials are derivatives of themselves. So I'm going to use a u substitution where I let u be e to the 2y plus 1. Because the plus 1, when I take a derivative, is going to become a 0. So I'll get du dy is just 2e to the 2y, which means dy is du over 2e to the 2y. Okay, so my integral becomes e to the 2y plus 1 is u over e to the 2y times dy, which is du over 2e to the 2y. Oh no, my e to the 2y's don't cancel. Okay, better idea. Simplify the integrand instead of trying to do anything fancy. So let's just get rid of all this. Instead am going to just simplify the integrand by dividing the denominator into each piece of my numerator. So this becomes the integral of e to the 2y over e to the 2y plus 1 over e to the 2y dy. So this becomes the integral of 1 plus e to the negative 2y dy. Integrate term by term. The antiderivative of 1 is y. The antiderivative of e to the negative 2y is e to the negative 2y over negative 2. Right? Because the derivative of e to the negative 2y over negative 2 would be e to the negative 2y over negative 2 times negative 2, and the 2's will cancel. Yeah, that works. Okay. Next. The integral of dx over x ln x. So this is the integral of 1 over x ln x dx. And because ln of x and its derivative, 1 over x, both show up in the integrand, I'm going to try a u substitution where I let u be ln of x. So du dx would be 1 over x, which means dx equals x times du. So my integral becomes 1 over x times, instead of ln x, I have a u, and instead of dx, I have x du. My x's cancel. This is the integral of 1 over u du, which is the ln of u plus c, and then replace u with ln x. So this is the ln of x plus c. Okay, this one definitely looks like a u substitution because I have a composition, and the inside of that composition is x squared plus 1, and the derivative is 2x, and an x also shows up in my integrand. So u, I'm going to let be the inside of the composition, x squared plus 1. Du dx is 2x, which means that dx is du over 2x. So my integral becomes x times the cosine of u over u. Oh, sorry, I left out the square root. The cosine of the square root of u over the square root of u times dx, which is du over 2x. So my x's cancel. I can pull that 2 as a 1/2 out of my integral. So this is the cosine of the square root of u over the square root of u du. Okay, I think I might need to do another substitution here because I still have a composition. I still have the cosine of the square root of u. So this is the inside of the cosine function is square root u. So I'm going to do another substitution. I'm going to use w this time. W is going to be the square root of u. which means dw du is 1/2 u to the negative 1/2, which means that du is going to be 2 u to the 1/2 dw. Okay, so now my integral, when I make this new substitution, is going to be 1/2 the integral of the cosine of w over w times 2 u to the 1/2, that's actually w, so this is going to be w dw. The w's cancel, and I have 1/2 the integral. Oh, this 2 cancels with my 1/2, so I'm going to get rid of that. Integral of cosine w dw. The antiderivative of cosine w is sine w. And then I'm going to replace w with square root u. And then I'm going to replace u with x squared plus 1.